Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all to the next session of a lecture series on Internet Working with Linux. Today's session is basically an overview of the working of the World Wide Web and architecture of web applications. We will talk about the three types of web documents: static, dynamic, and active, and the tools and technologies used to create them. Then we will touch upon Hypertext Transfer Protocol, famously known as HTTP, which is the vehicle that is used to move web pages over the internet. We will also talk about the overall architecture using which most web applications are built, particularly specifying different available web servers, web clients, and the server side as well as the client side programming languages. Finally, we will dig out detailed contents of HTTP request and response messages, and will practically see them using curl on a Linux terminal. Okay, dear students, the term World Wide Web was coined by Tim Berners-Lee in 1989. Let me move on to the board and start using it for better understanding. World Wide Web. It was introduced by Tim Berners-Lee in 1989. Well, it is actually a repository of information that is contained in documents called web pages. And these web pages are distributed all over the world on different devices or computers. Important point that I will like to highlight is that all related documents are linked together. This linking allows one page to refer to another web page stored in some other computer somewhere else in the world. This linking concept is called hypertext. And these days, this term hypertext has been replaced by hypermedia, as a web page can be a text document, an image, an audio, or a video file. Dear students, today's web has gone beyond the simple retrieving of linked documents. Rather, it is used for electronic shopping that you normally do on the internet, online gaming, listening radio, or maybe viewing television programs. You all watching this video right now is also an application of the World Wide Web. With this brief intro of the www, let me talk about the types of the web document. Types of web documents. Let me change color for this. The first type of web document that we like to talk about is static web documents, normally called the static web pages. Right, gentlemen, as the name implies, the contents of a static web document do not change. Let me write it. Contents do not change. So each request to a static document results in exactly the same response. The static web documents are prepared using languages like the famous HTML, hypertext markup language, invented by Tim Berners-Lee in 1991, I think. The latest version of HTML is HTML 5.0. Another one is XML, extensible markup language. It allows us to define our own tags and elements and thus create a customized markup language. Later, by combining the strength of HTML and XML, XHTML was introduced, extended hypertext markup language. It is quite similar to HTML but is more strict than it. For example, in XHTML, the doc type tag is mandatory. The elements must be properly nested, must always be closed, should be in lowercase. And this extended hypertext markup language started in 2000. Later we have CSS, that is famously known as cascading style sheet. Well, dear students, a simple web document is made of two layers, the content and presentation. Although it is possible to keep both layers together, separating them increases flexibility and reduces repetition. CSS is used to separate document content from document presentation. We can apply styles to elements using three types of CSS. The first is known as inline cascading style sheet. The second is internal, and the third one is external. Well, inline style sheet, you specify style to individual elements of an HTML document, while in internal style sheet, you specify style and then apply that style to a single HTML document. This is most versatile external style sheet. You place all the style rules in a file and save it with something .css extension. Later you link this style sheet to any HTML document you want. Right, gentlemen, the second type of the web document is known as the dynamic web document. Let me change color again. Dynamic web documents. Or normally called the dynamic web pages. A dynamic web document does not exist in a predefined form. When a client requests for a dynamic web document, the web server runs an application program or a script that creates it and then returns it to the browser or client. Let me write it down. A dynamic web document contents may change for every request. Contents may change for every request. For example, when a client asks for current date or time, or latest stock prices, or current weather conditions, or maybe the current availability of an airline ticket, a fresh document is created by server for each request and sent back to the client. Well, dear students, the programs that generate such web documents are called server-side programs. There are a bundle of programming and scripting languages that perform this task, and some of them are CGI, Common Gateway Interface, the Sun JSP and servlets, Python, PHP, Ruby, Node.js. Node.js is basically a JavaScript runtime environment for executing JavaScript code on the server side. Finally, the third type of the web documents is known as the active web documents. Active web documents. An active web document is actually a program that the web server sends to the browser and the browser runs it locally. Let me write it down. Programs sent by a server and browser runs them locally. Example of such a program is a program that creates animated graphics on client screen and maybe needs to interact with the client as well. Well, dear students, active web documents can be Java applets or maybe written in JavaScript as well. Well, now you know about the types of the web documents and the overall concept of the web. And you also know different tools that are used to create them. Let us change gear and discuss the vehicle that is used to take these web documents from one machine to the other. And that vehicle is Hypertext Transfer Protocol. Let me change board. HTTP, Hypertext Transfer Protocol. Let me write this down with red color, that this is a vehicle used by web pages to move over the internet. Move over the internet. Right, dear students, there are different versions of HTTP which come over time. Let me mention some important over here. Versions. HTTP version 1.0 was introduced in 1996 and it was non-persistent. Let me write it down, non-persistent. By non-persistent, I mean it required one TCP connection per resource. For example, if a web page contains a link to n different pictures in different files located on the same server, the connection must be opened and closed n+1 times. The next version was HTTP 1.1 that came in 1997 and it was persistent. Persistent connections. It provides a persistent connection by default, that is, the server leaves the connection open for more requests, or you can say that it reuse the same TCP connection and request multiple resources. More recently, HTTP version 2.0 came in 2015, which is binary instead of textual, is fully multiplexed, use header compression to reduce the overhead, and allows server to push responses proactively into client's cache. The other thing I would like to say is that HTTP is media independent protocol. Let me write it down. Media independent protocol. By media independent, I mean any type of media, that is text, images, audio, or video, can be sent using HTTP protocol as long as both client and server know how to handle the data contents. Then HTTP is stateless. By stateless, I mean both client and server are aware of each other only during a current request. Neither the client nor the server can retain information between different requests. However, today's web has to perform other functions which need a longer relationship that need to exist across multiple requests of different web pages. For example, uh, internet shopping. Well, yes, internet shopping allows a user to browse through different web pages to select items and put them on an electronic cart and finally pay the total price of all the items that are in there in the cart using a credit card. So here comes the role of another concept that is called cookies. Cookies. Well, dear students, a cookie is a small piece of data sent by server and stored on a client computer. When a server receives a request from a client, it stores some information about the client in a string or maybe a file, and that information can be domain name of the client, the timestamps, and maybe some other implementation dependent information like the code and the code and the price of the item that you inserted in your shopping cart. The server then include that cookie or that information about that item in the response that it sends to the client. And when the client receives the response, the browser stores that cookie in a directory to be used later. This is how the state is maintained. Okay, well, dear students, after brushing up the concepts of types of web pages and the hypertext transfer protocol, we are now ready to talk about the overall architecture of a web application. So let me change board, move on to the next screen, and talk about the architecture of a web application. Okay, let me draw a diagram for so that we can understand it in a better way. And we start by drawing a client over here. Let's suppose this is a machine on which our client program, maybe a browser, runs. Over here we have a web server. Let me write it down, web server. This is our client. The client sends a request to the web server for a resource or a web document. We called it a HTTP request message. If that request is for a static document, the web server forward that request to I suppose a storage for static web pages. So web server sends a static data request, static data request, and of course it receives the data response, and that response is prepared as an HTTP response message and sent to the client, and the client displays that response on the browser. So this is the case of a static document. In case of a dynamic document, let me change color. The web server forwards the request to another application that we normally call an application server. We call this an application server. The web server forwards the dynamic data request to this server. This server maybe queries some database, and this gets a response from here, and finally the application server sends the dynamic web page, and we call it dynamic data response, to the web server, which in turn sends that to the client, and the client displays that on the screen. So this is the overall architecture of a web application. So let me touch upon these components one by one. First of all, the client. Well, this client, or we normally call it a web browser, is a program for retrieving, presenting, and traversing information resources on the World Wide Web. Some famous web browsers in no specific priority are Google Chrome, we have Mozilla Firefox, and after Mozilla Firefox we have Safari, we have Opera, we have Microsoft Internet Explorer, and we have Netscape Navigator, we have Spartan, and there are others as well. Well, dear students, when using a browser, we need to give the address of the resource that we want to get from the World Wide Web. Broadly speaking, we need 4 identifiers. We need 4 identifiers to define the address of the web page. Let me write it down. Protocol. Then we have a colon and a double slash. Then we need to write the host name. Maybe an optional port number. And then we have path to the resource. Well, this protocol is the type of the vehicle to be used, that is used to fetch the resource. It can be HTTP, HTTPS, FTP, SSH, and so on. This host name can be an IP address as well that uniquely identifies the machine hosting the service. The port number is the port on which that process is listening. For HTTP, this is by default 80, and this is optional. You may not be required to write it. Finally, the path to the resource. This identifies the location and name of the file on the file system of target machine. Remember, gentlemen, it need not to match the exact path on the target file system. The translation from URL path to system path is taken care of by the web server. Let's move on to the web server now. Change color. Okay, this one is okay. A web server is a program that uses HTTP or HTTPS protocol, listens on port 80 or 443 respectively. 80 for HTTP and 443 for HTTPS. It waits for the incoming HTTP request and sends back HTTP response message to the client as shown here. Some famous web servers in no specific priority are Apache, An open source web server available on all Unisys, Mac, Linux, Microsoft. And to the best of my knowledge, more than 60% of the World Wide Web is hosted on machines that run this web server. And in our next session, we are going to install, configure, and use this famous Apache web server. Other than Apache web server, we have the Microsoft Internet Information Server, famously known as IIS. We have Nginx, which is suitable for embedded operating systems like Raspbian, as it has a very small memory footprint. We have Lec10. We have Jigsaw. And Jigsaw is a web server designed for W3C for the purpose of demonstrating new web protocols and other features. And we also have Oracle iPlanet web server, OIWS, which is designed for large business applications. So these are the different web server applications. Over here, this component, let me again use this color. These applications can be built using different languages like servlets, JSP, Python, Ruby. We talked about these before as well, Node.js. We say that these are the server-side programming languages. And finally, dear students, as far as the databases are concerned, there are a bundle of databases that are available. We will talk about MySQL or maybe MariaDB in some future session. It can be PostgreSQL. It can be Microsoft SQL, the famous Oracle, can be Informix, can talk about Teradata, maybe the famous MongoDB, and there are a lot of others as well. Okay, before, dear students, I close this theoretical discussion, let me touch upon the HTTP request and response messages on another board again. HTTP request message. Remember, we have seen that the client sends HTTP request message to the server, and server responds back with the HTTP response message. Let's see the contents of the request message first. Okay, let me draw it and then I will try to describe it a little bit. We have the first line, that is method, URL, version. In the second line we have different headers, header name, its value, you can have a lot of headers, an empty line, and then we have an optional body. Okay, I think that's enough. Okay, right, dear students, we have in every request message we have a request line, then we have 0 or more header lines, we have an empty line, and then we have the body. Right. This first line is the request line. It contains space separated three fields and end with a carriage journal line field. The first field is the method field, which defines the request type. And the request type can be get, which is used to request a document from the server, can be a head, which is used to request information about a document and not the document itself. It can be put, which is used to send a document from client to server. Post, which is used to send some information from client to server, not a document exactly. It can be delete, used to delete a web page. Can be trace, which echoes the incoming request, and maybe options, which inquires about available options from the server. Well, the second field, this field is the URL, and this is the version of the HTTP protocol. We have talked about these two before. After this request line, we have 0 or more header lines. Each header line sends some additional information from client to server. For example, the client can request that the document should be sent in a special format, and this information is sent using the header lines. As far as some of the header names you may come across is host, which shows the host and the port number of server. Can be user agent, which identifies the client program. Accept, which shows media format that the client can accept. You will normally see an asterisk over here. Accept character set, char set, shows the character sets of the client that the client can handle. Accept encoding, which shows the encoding schemes that the client can handle. Maybe accept language, which shows the language that the client can accept. Well, there can be a lot of header names and their corresponding values separated by space, which are sent by the client to the server. Then we have an empty line, and finally there is an optional body. So this is the HTTP request message. Let's on the same format, let me draw the diagram of a HTTP response message as well. HTTP response message. Let me draw it as I have done before. First line is version, and we have a space, status code, then we have a space, then we have the status description, carriage done and line feed, and header name, followed by a colon and a space and the value, then carriage done and line feed. We can have a lot of header lines, then an empty line, then we have the optional body. So this is the overall structure of an HTTP response message. As usual, we have the first line as the status line, then we have 0 or more header lines, we have the empty line or blank line, and then finally we have the optional body. Well, dear students, this status line contains, first of all, space separated three fields and followed by a carriage journal line field. The first field shows the HTTP version. We talked about this before. And the second is the status code. Let me write it over here, status code. Well, this is a 3-digit integer that defines the type of the response or the class of the response. If the code is in 100 range, that means the message is informational. The code in 200 range means a success. For example, 200 is OK and 202 is accepted. The code in the 300 range means requested page has been redirected and further action must be taken in order to complete the request. The code in 400 range indicates error. For example, you all must have seen the 404 famous error message, that is 404 means page not found, 403 means forbidden page, and 401 means unauthorized. Finally, the code in 500 range means server failed to fulfill an apparently valid request. For example, you may come across error 505, which says HTTP version not supported. Then we have a brief description of this status code, and after that we have a lot of header lines, and these header names can be, let me write it down, header names. The different header names that an HTTP response message may contain are the date, the server, the last modified e-tag. Well, e-tag is a string that identifies the modification of the data requested. We have accept ranges, content encoding, that is the encoding scheme used. We have content length, that is the length of the document. We have content type, that is that specifies the media type which is there in the body part. We may have the set cookie header name in one of the header fields. That is, the server asks the client to save the cookie over there. Then we have an empty line, and finally we have the body part which contains the actual data that is sent. Well, gentlemen, before I close, let me move on to our Linux terminal and just briefly touch upon what we have done at the final part, and that is HTTP request and response messages. If you want to dig out the details of HTTP request and response messages, you need to install a tool that is called curl, sudo apt get install curl. Let me do man curl. Okay, curl is a tool to transfer data from or to a server on command line, and support a lot of protocols like dict, file, FTP, FTPS, Gopher, which is a predecessor of HTTP protocol, IMAP, that is Internet Message Access Protocol, used by email clients to retrieve email messages from mail server, LDAP, LDAPS, and so on. Well, LDAP is Lightweight Directory Access Protocol. Okay, please do read this man page at the time of your ease. Let me use this for you in a very simple way. I use curl http colon www.google.com. Okay, if I do it, you can see The status code is 302, which means that the requested page has been redirected to this link. Okay, so let me clear screen and use curl -v option. With this -v means verbose mode, and in this mode you will see the contents of the HTTP request as well as HTTP response messages, which we have discussed. If you see over here, the portion which I have highlighted, these are the 3 lines of HTTP request message. 3 lines of the HTTP request message. This is the request line, which contains the method, the protocol version, and this is the header, host, user agent, accept. This is the empty line, and there is no body in it. As far as the HTTP response is concerned, you can see this highlighted portion is the HTTP response. This first line is the status line, giving the status code 302. That means the page is found, and these are the different headers: location, cache control, content type, p3p, date, server, xframe option, set cookie, and so on. And finally, here is the actual body part of that. Okay, so please do dig out more details about HTTP request and HTTP response messages using curl. And dear students, this session has gone a bit longer than my expectations. Again, we are done with the overview of working of the World Wide Web and the overall architecture of web application. And I think we are now well equipped for installing, configuring, and using any web server, and we will be using Apache web server in the next session, inshallah. And I hope it will be fun in the next session. Well, students, I hope it was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Happy learning, and Allah Hafiz.